Hello, today we are going to talk about the differences between standards, controls, and calibrators. Firstly, we would like to explain Beer-Lambert Law. If we have a color solution with unknown concentration, and this color solution was inserted in a spectrophotometer, the light with a specific wavelength will strike this solution. Some of the light will be absorbed and the rest will be emitted. The amount of light absorbance is directly proportional with the concentration of that solution. This is what Beer-Lambert Law states for. And this is the mathematical formula of Beer-Lambert Law. The mathematical formula of Beer-Lambert Law indicates that the unknown concentration usually measured using a known concentration solution. This known concentration solution is called standard. So what is a standard solution? Actually, to understand the definition of a standard, let's explain this example. Suppose we have three tubes contains three different concentrations of a solution. The concentration as shown indicated by a color intensity of the solution. So A has the lowest concentration, A solution has the lowest concentration, B higher concentration, and the C solution has the highest concentration. Suppose that these three solutions have been read on a spectrophotometer, and solution A gave 0.3 value. B solution gave 0.9 value, while C solution have a read value 1.8. If A solution has a concentration as 10 milligram per deciliter, so B solution that gave a value 3 times the rate of A solution will also have a concentration 3 times of the concentration of A. So B concentration will be 30 milligram per deciliter. In the same manner, C solution that has a value 1.8, 2 times the value of B solution, so the concentration of C will be 2 times the concentration of B. So the concentration of C solution will be 60 milligram per deciliter. So B concentration is 3 times the concentration of A, C concentration 2 times the concentration of B. The reference solution here is A. A has been used to evaluate and measure the unknown concentrations in B and can be used also in C. The value 1.8 is 6 times the value of 0.3. So if we directly calculate the concentration of C using A data, so 6 times the concentration of A solution, this concentration is 10, so this concentration will be 60. In the same principle, standard can be used to be compared with the unknown concentration. Thus, the concentration of the unknown can be determined. As we see here, the known concentration used to be compared with the unknown concentrations, and the unknown concentrations can be determined using this known concentration. So if we would like to define standard solutions, so these are solutions in which concentration of a given chemical is precisely known. They should be used to determine the value of an identical chemical with unknown concentration of a given solution. For example, if the glucose concentration will be tested in a plasma sample, the standard solution will be a solution of glucose that its concentration is precisely known. Chemicals that are used to prepare these solutions should be of analytical grade. This means that the standard solution should has stable composition and unchanged concentration. So the solution should be stable. The quality of standard solutions usually related to the accuracy and precision of laboratory finding, since poor standard solution causes error in the estimation of the unknown concentration. Thus, standard solutions should be prepared carefully and in accurate concentration. By talking about the classification of standard solutions, there are two types of these solutions. The first type is a primary standard solution. This solution has the highest purity. It's made of a highly pure substance, and it's directly used to measure the unknown concentration. This is what we usually use in the medical kits. For example, for these types of solution, sodium chloride, sodium bicarbonate, potassium iodide. The secondary standard solutions are solutions with lower purity. Its concentration should be determined using the primary standard, and then this secondary standard solution can be then used for analytical procedures. For example, for this type of solutions, nitric acid, hydrochloric acid, and sulfuric acid. As the primary standard should has the highest purity and should be made of an analytical grade substance, a primary standard solution should be made of a substance that are free of impurities, should be highly pure and stable in composition. So this substance should be not hygroscopic, not absorb moisture, and not vaporize at room temperature. Should be stable, and this substance should be accurately weighed or measured, and the concentration should be known precisely. Because the quality of standard solutions are involved in the accuracy and the precision measurement, so our results are only as good as the used standards. The second type of the solutions to be explained today is control or control solution. Controls. Have you ever asked yourself about the result of the test you performed at the lab? Whether these results are enough good, accurate, or represent the status of patient? This is why controls can be used to increase confidentiality as well as insurance that the work output and the work data or lab findings, lab test result adhere to the quality measures. So what is controls? Actually, to understand the definition of controls, let us explain this example. If a sample tested for a glucose concentration and the result obtained is 200 milligram per deciliter, another reference or control sample that expected to have a glucose concentration within the range from 60 to 120 milligram per deciliter. If this control sample has been handled and tested as the same way and condition of the sample when being tested, and the result obtained within the given range between 60 to 120. This increases confidence about the result. But if a result obtained fall outside this range, this may indicate an error. So control sample or control solution can be used to test myself if I work and adhere to the accuracy and precision measures or not. And control samples used to test whether my system, my work condition that include the instrument, reagents, the pipetting, the patient identification, the sample processing, everything from patient identification and getting sample till the result measurement. All of these steps called the system and the test condition. تمام. So control sample can be used to test whether this system or work condition working properly or not. Quality control samples are expected to be identical with the same matrix of patient samples and should be tested identically to the same manner or same way patient samples tested. Should be treated not as a special case. And these samples used to validate precision and accuracy of the results of patient sample testing. And also can be used to evaluate how good the results obtained they are. Control also have levels or classification. Control samples have levels or classification. There are three types of controls or three levels. High level controls that used when the parameter to be tested in the sample are expected to be high. A high level control should be used and tested in a parallel to the sample. In the same way, low level control used when the parameter tested are expected to be low, while normal level controls used when I want to know if the system gives good results when the testing parameters are expected to be normal. Controls also can be classified as normal or abnormal controls. High level controls and low level controls can be considered as abnormal, while a normal level control considered as normal. Control samples or solutions should be used in a daily basis, specifically with each run during a month. A day-to-day control result should be used as a set of data to calculate the mean, standard deviation, and to plot the obtained data on the Levy-Jennings chart to observe whether there is a trend shift or a value outside the 2SD border or values outside the 3SD border. All of these cases indicate a type of error. We can explain the Levy-Jennings chart and its details in a separate video. At least right now we want to know that control sample results should be plotted on Levy-Jennings chart and to monitor the distribution of these results to detect the error. The third solution we want to talk about is the calibrator. To understand what is calibrator, let us explain the term calibration. Calibration is showing that a specific instrument or device produces output with an indicated restrict. Even calibration is used to detect to detect whether the instrument working properly, giving acceptable data or not. Calibration is usually done in the beginning of run. Calibrator to a certain limit resemble standard. Standard that come with a kit can be used to calibrate the instrument for one parameter or in one parameter because standard is a solution of one composition. Multiple parameters can be calibrated using a high-quality calibrator, so calibrator can be considered as a multi-parameter standard. So calibrator can be used as a standard and can be used to produce a calibration curve from which a concentration of unknown concentration can be calculated of unknown solution. Here, if we want to differentiate between standard, control, and calibrator, according to the matrix, standard is a solution with a pure matrix. It's a pure solution, contain just the parameter to be measured and the same composition of the substance to be tested in patient sample. Control have the same matrix of a sample, while calibrator could be a pure solution or could be the same with human samples or patient sample. According to the patient sample in comparison with a patient sample, standard is a solution of the chemical to be measured, while control contains several chemicals. Calibrator mimic human samples or could be multi-parameter solution. Concentration of these solutions, standards have definite value or definite concentration, precisely known concentration, controls the concentration of the several chemicals in these samples or solutions can be determined as a range, not a definite value. Calibrator can be used instead of standard, so it to a certain limit resemble standard, or standard can be considered like calibrator. So the calibrator have definite value for each parameter contained. The use of standard is to determine the unknown concentration. Controls used to validate accuracy and precision and to test whether the working system and working environment and working condition is enough properly or enough good, doesn't produce error or not. Calibrator can be used to adjust the instrument. Here, the solutions compared with the first, according to the first item, the matrix. So what is matrix? The matrix is everything except the analyte or the parameter to be measured. So consider a plasma sample to be tested for glucose concentration. So the matrix of this plasma sample will be everything except the glucose. All components of the plasma other than glucose will be the matrix. If a urine sample wanted to be tested for the protein, so everything in the urine sample, each component in the urine sample other than or except the protein should be called the matrix. So the matrix is the sample subtracted from or the analyte subtracted from the sample, or the analyte removed from the background. So the background of the analyte can be considered as the matrix. This is the end of this lecture. I hope you enjoyed the lecture. For any question, please write to me in the comments. Your opinions are welcome too. So, thank you.